Greetings, this is Artie from Artifact Electronics. In this episode we'll be having a look at a Ms. Pacman arcade game, and this is actually the mini version, also called a cabaret version. This belongs to a friend of a friend whom I don't know, but my friend asked me if I could have a look at it because it was broken, and I asked him what was wrong with it, and he said, I don't know, because his friend just said it was broken and if he could get it fixed. So I guess so I'm a pointer to my friend, and my friend is a pointer to his friend, so I'm a double pointer, but I don't know what I'm pointing at. Anyway, the bottom line is that this thing needs to be looked at and brought back to life. And I love doing this kind of stuff. So let's have a look at this cabinet. It is in pretty rough shape. I mean, the sides of it look like it has a lot of water damage on it. As a matter of fact, when we got it off my friend's trailer, the bottom was beginning to fall apart, and he didn't hesitate. He went to the front of the truck, got 2 nails and a hammer, and nailed the bottom back together. Yeah, it hurt, but it's not as if I'm interested in buying this game or anything. I'm just doing him a favor. Yeah, looking at the bottom, things are beginning to peel off. And the game itself, well, I guess it looks okay. We got the marquee there. We'll find out what the monitor's like. I mean, the video camera makes it look a lot better than it really is, but yeah, the bottom is also... The bottom was actually horrible. All the metal feet were rusted. That's why I put it on cardboard. This side actually looks a little bit better than the other side. And looking at the back, so here's the back. Also, the bottom is in pretty bad shape. It's got this weird protrusion here, but we will find out in a second why that is there. And you will notice that the back door is being held in place by a piece of tape. And that's because the door won't fit into place. And what I think happened is the bottom rear wood piece got impacted, i.e. it got dropped and kind of inched up a little bit. And so now the opening for the back door is not high enough, and thus the door won't fit. And we actually can't even turn it on like that because there is a safety interlock for the power in there, and that doesn't engage with the door not closing. So let's take that door off and power it up, see what happens. So I opened up the back door, and we can see that protrusion in the back door is to accommodate the edge of the monitor frame, which, if we look at it from the side, sticks out quite a bit. And for whatever reason, they decided to not make the cabinet deeper, but rather come up with a plastic part for the monitor frame. That actually makes it really awkward because you can't dolly the thing from the back because of that plastic protrusion. But anyway, going on, when I opened it up, basically the PCB was suspended by the edge connector, just hanging in there. Ms. Pacs also have a security board that plugs into the main board, and without which it won't run. So I believe that bootlegging of Pacman had become so rampant that this was their solution to kind of prevent that. But I've kind of arranged the board in a way that it's not touching anything. There's no shorts, nothing shorting against anything. And the way to turn it on is, here's a safety interlock. And the safety interlock, when the door is in place properly, just gets pushed in and completes the AC circuit. But since my door won't go in, that is kind of useless. However, it does have a service position. And that service position basically says pull out the switch, and when you pull out the switch, the machine will turn on. Alright, so I just double checked again to make sure nothing's shorting against anything. It's kind of awkward, but seems to be stable. So now what we do is we put the switch into the service position. Alright, I hear lights. I hear lights. I see lights come on. So the coin door lights up. The marquee lights up. But the screen is basically solid white. Well, almost solid white, because it's basically showing in a whole lot of burn-in on the screen. And those diagonal lines you see are just the camera having a hard time syncing with it. They're actually not there in real life. So, let's see, can we coin up? So, no noise, no sound. Nope, nothing's happening. So it looks to me like, well, obviously the monitor's coming on, which is a good thing, but there's no activity from the motherboard. So let's go in and do the first test. Alright, so here we are. I got the security daughter board out of the way using a hopefully non-conductive rag for insulation there. And if we look inside at the power supply, it actually consists of two transformers. One of them on the left is just an isolation transformer from which the monitor gets AC, and the one on the right is what powers the game and the lights and everything else. And let's see, you can see the two fuses over there, which are for the AC to each transformer, so they have separate fuses on there. And then we have another 4 fuses over there, and the way this thing works is the transformer supplies 14 volts AC center tapped and 24 volts center tapped, and basically each leg is fused. And when I checked the fuses, the two on the left were okay, which are the 12 volt legs, but the ones on the right, which are the 7 volt legs, those were both blown to smithereens. So I checked the old fuses, I did some checking on continuity and stuff like that for obvious shorts, and nothing was there. So I replaced the 2 fuses on the right, and there had been the correct value fuses in there after I checked. And so now is the time to try to turn it on again and see what happens. So after moving a respectful distance away from the machine, well, something happened. And we have a picture. Well, it's kind of really bright, and it looks to me... Alright, I'm going to have to go in and basically adjust the... Let me go and adjust the brightness on the flyback and see what it'll look like after doing that adjustment. But it looks like the video is running perfectly. I can see no red on this right now, or very little. So either the red gun's gone or the brightness is just totally wiping out the red. But yeah, let's go and... Unfortunately, I can't film it because I don't have 5 arms. But all I'm doing is going to the back of the flyback transformer, which has a focus and a brightness control on it. And I'm going to turn the brightness control down till this hopefully starts looking normal. So I did look at it, and I noticed that the red was definitely missing. And again, one of the first things was the machine is kind of dirty inside. So what I did was I removed the RGB connector coming from the PCB and going to the monitor, and just removed them from the monitor chassis, blew some air on it, and inserted them a couple of times, and it looks like red is back. So now let's see. I think I figured out a way to film it. I know it's very exciting filming while adjusting the brightness, but hey, you know, let's see. I gotta get my hand on the proper control first while this thing's all over the place. And then we actually get a really nice display, except it's beginning to look now like something's interfering with the top of the screen. Look at that. I think it needs to be degaussed or something. Now I know these monitors are pretty sensitive to that kind of stuff, and I got a lamp behind it. Let's see if moving the lamp makes any difference. Alright, I moved the lamp out of the way. I know these monitors are really sensitive, and it fixed the problem mostly moving that lamp away, but I think we still have a bit of a degaussing problem up on top. Let's go ahead and power cycle it, because we know that the degaussing circuitry kicks in the first couple of seconds after you turn on the monitor. So let's leave it off for a while. And there we go again. Yeah, see, the top writing is showing up in white now. So let's wait till it goes back into demo mode and see if things are okay. Yep, fix the top of the screen. So it got slightly magnetized by the lamp I had behind it, and just power cycling it, we got a good white color back on top of the screen. So now, of course, we got to play a game. Alright then, let's see if we can coin it up. Well, I can hear the relay clicking. It's supposed to make a noise, and it is not making a noise. And the machine just reset, because the credits went back to 0. Hello? Alright, so we got a bit of a problem here. Every time I coin up the game, it resets. Alright, let me go and check connectors. Alright, I think I found the problem, or at least how to prevent the problem from happening. And if we look at this, so I'm able to coin up now. Obviously there's a problem with the sound, but it's not resetting. But now watch, what if I, when I'm coining up, I'm basically simulating a coin falling down, which activates a switch. Now if I hold that switch down for a while and let go, well, the last time it resets, so there may be something awry in there, but hey, we got it to work now. So let's see. Yeah, all I can hear is clicks that aren't very loud. I mean, the game's playing fine. but there is no sound. And the cherry's making a noise. Well, but it looks like most of the problems were fixed by replacing the fuses. But now we gotta have a look at the sound. Now, after testing things a little bit more, the reset, aside from the sound not working correctly, the reset seemed to happen whenever certain sounds were being attempted to be generated. And since we don't have any sound at all, obviously the problem lies in the sound section. Now we hear rhythmic clicks, which means that the processor is probably sending out data, but it's just not getting processed properly. And a quick look here at the sound generating circuitry. Let's see. So basically, we have these two 2-to-1 quad 2-to-1 multiplexers here that are directly hooked up to the data bus, and they somehow gate the data coming off the data bus into both of these. What are these, latches? Can't see what they are. Yes, they are into these latches, and the clock inputs, or the write enable inputs in here, enable these at the proper time. So you end up with a total of 8 bits of data on the other end, going through some multiplexing scheme. Then where that ends up is, again, what we have over here is data gets, let's see, the data gets multiplexed and latched, and same thing here. And what we have over here is a 256 nibble prom, and the data gets multiplexed into doing an 8-bit to 4-bit conversion over here, and that stuff goes yet into another latch. And what that does is, this is a simple nickel and dime D to A converter, 4 bits. Well, actually, it's more than 4 bits. It's 4 bits for the actual value. And then there's a 4066 quad CMOS switch in here that further shapes the sound, and that is just piped into power amps. Now, the power amps are working, because otherwise we wouldn't hear any clicks at all. Whenever I look at a troubled section of circuitry and I see 40-year-old CMOS chips that don't have a B or higher suffix, I don't even mess around. I pull them out immediately and replace them. So when I did that, I noticed something very interesting, and that was that this prom over here was missing. It was just an empty socket over here. So obviously there was no data getting gated. There was some data getting gated in, which is probably these top 3 lines which were causing the clicks. But the real data that's creating the analog sound was random, or, depending on whether it was pulled low or high. And so there was no sound generation whatsoever. So after replacing this, I had to go on a hunt and see if I had one of these proms. I don't have the equipment to burn one of these. I'm sure I could get the actual binary file for it, but I can't burn any of them. So after a lot of searching, I actually found one of these proms that came off a Pacman board, though, not a MISPAC, and I do not know if they're identical. But let's put the prom in. We have the new 4066 here, and see if that makes any difference. So here's a physical location of the components. And what we have here is the 4066 I replaced and socketed. Here is the empty socket that should contain the 8-bit to 4-bit conversion prom. That isn't in here, so what I'm guessing is that this game was run without sound, or with clicky sound, for a long time. But let's put that prom, the Pacman prom I found, in here, and see if that brings this thing back to life. Let's try this again. Alright. Coin up again. Very promising. Except it reset. Can we coin this thing up without it resetting? Okay. Well, there is some sound, but it's pretty incorrect. Yeah, sounds are missing. So I think we gotta probe the remaining chips in the sound circuitry and see what else may have gone bad. Well, I didn't get anywhere. The problem just kept persisting. And so finally I decided to use my head. Not to think, mind you, but to put it on a pillow and sleep and see what the new day would bring. And the new day brought a whole lot of unrelated problems, but finally I did start thinking, and I figured that prom that I replaced, even though it had some of the right sounds and some of the wrong sounds, it's an 8-bit to 4-bit conversion lookup table. What if that wasn't the right what if that wasn't the right prom? Because they were labeled very ambiguously, and just the fact that it did create sounds led me to believe that it must be correct. But I guess maybe it isn't, and I'm trying to change the wrong problem here. I mean, I hooked up the scope and I measured all the pins in the sound circuit, and everything, I mean, it looked fine. Logically, I don't know. I didn't hook up a logic analyzer, but levels were fine, transitions looked fine. So I decided to try to solve the problem of was it the right prom or not. I went and saw my good friend JP and made him a deal. I said, give me all of your busted Pacman boards and I'll fix them for you. And he said, why would you do that? I said, because I'm a nice guy. And then I told him that I need parts off of his boards, and he gladly volunteered to have me take the boards, not because I was going to take parts off it, but because I was going to end up fixing them. So here we have, I mean, it's a Pacman board, not a Pac, but they're very identical, except that the Pacman doesn't have the daughter board on it and just has a processor in that socket, whereas where you see the ribbon cable coming out there, that's the daughter board plugged into the processor socket. So I took the chip, the prom, which is in the picture, this on the bottom row, the second chip from the left, and plug that one in. And let's see what results that'll give us. So, credit. And it sounds correct now. But there's a droning note now. Very similar to what we heard before. The sounds are correct, but there's an extra note droning in there. Now this game has a test mode. When you put it in test mode, it kind of reboots and then does kind of a sound test in that by pressing buttons and moving the joystick, you can get different sounds to play. So if we switch it to test mode, it starts playing a sound immediately. So there is the drone, a different drone, but it's playing a sound effect. The directional stick and the buttons both created sound, but I noticed that when you're pressing the stick down, it did not it didn't create a new sound, and it was almost like that constantly playing sound was what should get triggered when you're pushing the stick down. Ergo, something must be the stick, the down position switch, or the detection circuitry for that must be stuck. Now I need to add that I did plug in one of the Pacman boards I got from JP that was in working condition, and that one worked just fine. That to me indicates that the problem is not in the external mechanical part of the joystick, but rather somewhere on the board. I probed the input coming from the down direction switch, and lo and behold, the logic probe told me that it was stuck at 0. All the others were high, and we'll go through a quick explanation to see what that means. The reason I'm not showing you that on video is I didn't have the camera turned on, and I'm too lazy to set it all up again, but it's really inconsequential because I can actually show you here or demonstrate the problem. But if we look here, this is where the switches are coming. The one end of the switches are coming in, and the other end of the switches are connected to ground. Now when the switch is open, and the problem is our down switch over here, is normally they got pull-ups to VCC or 5 volts. So under normal circumstances these are high, and they fit this buffer, they feed this buffer with a high voltage. So when the processor comes and reads it, it gets a high coming out of it, and it knows that the switch isn't pressed. Now when each respective switch is engaged, or specifically the down switch is engaged, this input goes to ground, grounds this junction here, so the pull-up can't do anything anymore, and we now get a 0 on the bus, and thus the processor knows that the switch has been pressed. However, if the input on pin 14 over here is always low, the processor is going to think that the joystick's always in the down position, and obviously do some strange things. Now I can't explain to you in detail why the game would work at all. I can still go up and left and right and all of that. I don't know, that depends on how they interpret the entire byte that they read over here coming from the switches. But again, that's inconsequential. We found a problem. Now we have to find the physical problem to see why that is always stuck at 0. And the best way to demonstrate this is we will do a continuity check on the chip in question. And that chip is 8E, pin 14, which is over here. And we measure it against the ground plane over here. You can't see the meter. It's not a dead short. It's showing about 20 ohms, but enough of a short to make the machine think that that switch, the down, is continuously pressed. And I'm not sure how that would affect the gameplay sounds, but obviously in the test mode it's continuously droning that one sound, indicating that the game thinks that the down joystick is pressed all of the time. From the schematics we could see that every input from a switch basically had a pull-up and from the same junction a bypass cap going to ground. And my suspicion was that the bypass cap going to ground had shorted. I lifted it, and that wasn't the problem. We were still, this being the junction for the switch in question, was still shorted to ground. So finally I went ahead and I cut the pin on the buffer on the 367 that received the input signal. Now, let me get the meter. You can see that the junction no longer has a short to ground, but if we measure the cut pin, which right now isn't connected to anything except the chip, so the input pin on that chip went bad, and that's what's shorting it to ground. So here's the bad boy, an LS367, and I guess he needs to be replaced, and hopefully I have a replacement in my box of tricks. I removed the bad chip by cutting the pins over here, and then just pulling out the pins, heating each hole to minimize the risk of trace damage. And there's the result. It's all clean. What I'm going to do now is clean the pads from both sides with IPA, isopropyl. And very important in a case like this is you need to flux the pads, especially on this side of the board, because they're going to get soldered from the other end. And if it isn't properly fluxed on top, sometimes the solder doesn't flow all the way through. So make sure to be generous. Well, not generous. A little bit of flux will go a long way, but do use flux before putting in a socket. So it's about 2 hours later. I put the socket in, the chip in, and it still acted up. It acted up differently, but it was still acting up. We're in test mode right now, and it was playing weird sounds all the time and not responding. But I think I found it. So now, by moving the joystick and pressing the buttons, so that all works. And what the problem was the wire harness on the bottom of the coin door was hacked and put together really badly. It left exposed strands of wire that could touch anywhere. And since there's 12 volts in here for the bulbs, I think what happened with the LS367 was one of the wires, the input wire coming from one of the coin switches, must have inadvertently touched or shorted to a 12 volt line in here, and that would explain how it took out that input on the 367, because I couldn't figure out. I've never seen that where an input just goes bad, gets stuck low. But I took the whole thing apart, put shrink tubing over the exposed areas, and redressed the whole wiring, put new zip ties on it, and now that looks really clean, and the game seems to work. I also put the board back cleaned up here in the back, put the board back in, which you can't see. You can kind of see there's a board, and then in the background is the security board all screwed back into place. And I think that concludes the repair of this Pacman. Now, there are some outstanding issues here. One, of course, is the cabinet itself. That would need to be refinished. The back door doesn't fit because there's damage to this bottom piece of wood that's probably been shoved up and you can't close it properly. There needs to be a full recap of the motherboard and a full recap of the monitor chassis, which you also can't see, but it's just a monitor chassis, because I get a distortion on the right side of the screen. Let's switch back to game mode here. I'm going to play a demo game, and then you can see there's some distortion on the far right vertical part of the screen. But other than that, it's back together, the sound is fixed, and I think she plays well now. So thanks for watching. Give me a thumbs up if you think it was worth spending countless hours on this, bringing it back to life, and make sure to subscribe. That leaves us with the best part of this episode, at least for me, and that is giving it a little more extensive play test. But before we get to that, it bothered me that the wire harness had been hacked, and I did look at it a little bit more closely, and I can't be 100% sure, but it looked to me like what had been done was it was rewired so only one of the coin switches would activate the counter, the coin counter that's inside. There's a mechanical counter there. And the other one was, they did some weird thing to rewire it so it would not activate the counter, which means on average the counter would report half of the number of coins dropped. I'll leave it up to my illustrious viewers to draw a conclusion from that. But anyway, here we go. Keep in mind that my hand-eye coordination isn't what it used to be, not that it was anything great before, but I guess my internal wire harness isn't in that good a shape, but here we go. Wasn't supposed to do that. Danger. Danger, Will Robinson. Whoa. So far, so good. Are we all having a good time? I am. Come here, my sweets. And he got away. Well, at least I got to the first cutscene in here. Which is also a good test to see if the music and the non-standard graphics work. User error. At least let me get a free Pacman. That's gonna cost me. Greed doesn't always work. I should have let it go. But I did get a free Pacman. Close. Hey. All right. Not much more to do here. Probably won't make it to the second cutscene. Hey. Pretzel. No pretzel for me. I had to get the pretzel. Game over, dude. Anyway, we'll see you in the next exciting episode. Bye.